it's more meaningful for you to. I think assignment is more effective if you is really done it yourself purely, without extensive help from others. I don't know how many you got help from others. When you are that life fighter, I think probably you need to get help from others. Otherwise, I don't think you can complete the assignment. And based on the quality of the assignment report, I can anticipate. Although I cannot prove, some students may get extensive help from others. Something that is extraordinary, unless you are really a good programmer, you have extensive knowledge in programming, some work may not be able to be done by you. Okay. So this is the first unit. It gives you, in this examination, normally my practice is exam question will cover almost all units. Almost all units. So even for this unit, its general concepts is still cover. But you need not to memorize all the details like this one. This is only an example to tell you. But this will help you to get better understanding. You need to know this type of example, typical questions is tell you to think what it is and how you can what it can be done for the cases. Only after you go through this one, then when you look at the questions for the cases, you know which cases apply. Without that background, if you just read the first few slides and then try to answer the question, that's really difficult. It's pretty similar to I think case studies. When you have learning something by case study, then you need to read many cases before you can generalize and the concepts delivered in the cases, and then try to apply what you get from the cases to another cases, a new cases. You are human. How you learn is based on readings. You read a lot, see a lot of different cases, and then you try to generalize, reorganize in your mind. At the end of the day, you can apply what you have got memorized, and then you can solve a new problem. Without going through that process, I don't think you can do that. This is real. Okay, I'm a researcher. I study for many years and do research for 20 years. So this is my experience. How we solve a new problem, more or less based on something that we learned maybe many years ago, but memorized in my mind. Then one day when I get similar problem, I can pick up and then try to solve it. So you see a lot of examples. I think you better go through some of example, get some better understanding of this. What I mean by this is show you the different stages, this kind of concept. You need to be aware, and you need to know how to apply them. Help company to become a leader, for example. This is steps. So the first unit is focused on this one, and the main part is that one. Second unit is on data visualization. Most of you just follow the samples that I give you to plot graph, and I told you, because the data set this time is very, very special. All the variables except the age is chronological. So in fact, you can still use bar chart, frequency, just count the numbers for different cases. That's still fine. But that is not really solid. At least you tell me the percentage. But only few of you can know that you not only count the numbers, but the percentage. And maybe the best, you can use some even statistical chi-square hypothesis to do that, to further support that some variable is more related to the cases, some may not. And the second part, graphical methods, is it tells you the basic data processing for analytics. This step is you go through already. You must be very clear. Okay, this step actually is whatever. No matter we are solving for any data analytic problem, we go through similar step. We go through similar step, regardless of the methodology, whether it's supervised learning, unsupervised learning. We all go through these steps. We need to consolidate the data, get the data from the company. It tells you the framework and how to. You need to clean the data. You do similar things, and some of you, but you are lucky enough this time you do not have missing data. And that kind of data cleansing process, you do not do it, but do some transformation. Some of you use normalization, but without saying the word why you normalize. A little bit disappointed. You should tell me why you do that operation, why you need to normalize it, or why not you normalize it. And some of you try to discretize the age, but I don't see the point why you need to discretize the age in this problem. For exploratory, that's fine, but you just plot a histogram. Then that is already discretized. Histogram is you have bar width. And then you may have some of you have talked about you think some variable is regardless of the two cases, the counting are similar. So to try to eliminate that. Well, I can see the point. Some variable, I can't remember exactly the variable name. Whether the patient have illnesses because they try to plot the graph. For particular type of measures, and one bar for yes, the other for no. Typically, you draw this one. This is target variable, and this is for x. And when this two bars is more or less the same, because it means that this measure may the number of patients with yes and no is similar. Then they try to conclude that variable is not really useful for predicting whether the patient have diabetes. And it seems good, but actually, you just overlook one thing, that because there are so many variables, we don't know how the variable mix together for a patient with illnesses. So just singling out, try to evaluate this based on this graph may not be really fair, because the illnesses, whenever you have to check for doctor checking the illness, confirm the illnesses for a patient, they not only look at one factor, they look at multiple factors. Sometimes they vary more of the occurrences of the positive case for two particular combination of measures. So this is just singling out is a little bit risky. Okay. So you go through all this one. We talked about the general concepts. You need to know how to apply it, and you need to know how to apply this one whenever you have to model a problem, propose a method, how you actually implement. You need to be able to mention the step in data analytics process. And this is an example illustrate the real cases, and you just go through in the assignment, suppose. And there's basic statistical descriptions. I don't think this is one that we really need. This is not for this course. Actually, this is a statistical course. But for exploratory analysis you performed, we introduce this. We introduce this just for the sake that you need to perform exploratory analysis. And of course, this kind of knowledge is very important for B452F multivariate analysis, statistical courses. For exploratory analysis, we introduce quite a lot of graph, but I don't think you already apply some concepts. The statistical part is not the one is for focus. But at least you for this course, when you do the assignment, you need to get back to this basic concept. If you do not have this concept, you do not know how to read the output. That is very important. The statistical concepts. So to present, we also talk about dashboard, how to generate report, that kind of concepts. I think this is not something very long discuss. We only briefly go through. So and then there's a lot of graph. There's a lot of graph. Just have an overview, that's fine. Okay? You need not to memorize every graph. I will not ask you explicitly. Later on, you see the question type. You will see. Most of the questions will be open-ended. Most of the questions in the examination will be open-ended. So subject to your proposed method. For each method you propose, you should be able to tell me what is pros and cons, why you select that, and not the others. That kind of concept. Also, some basic theory or related to the methodology, because for example, SVM we have the method models. What is the method models? And for neural network, we have neural bases inherent based on the human brain ideas, how we model the problem. At least for that overview is required. And so whether you need to explicitly memorize this kind of the name of the different graph is up to how you answer the questions. Okay, there's a lot of detail that is for more or less get an overview. And in the assignment, I think you, as I told you at the day one actually, most of you will use bar chart, box plot, that kind of more. And all the other is fancy graph that is nice to have. If you can use fancy graph I'll give you a little bit more mark in the assignments. So chapter 2 is data visualization. So we will not ask the question in this way. What is thematic map and how to use it? That's not the question for this level. Understand? Hope you get what I mean. I won't tell you what will be covered and not covered in the exam. And starting with the third unit is very important because this is the main part. We talked about the predictive analytics, and we go through some idea about the tasks. We talk about the data mining process. Something very important when we have to perform a project. When you have to perform projects, then you better to follow some standard to guide through your projects. So to guide you to complete the projects. So we have different project methodology. This is a project methodology talking about the quiz PDM, the CIMA, the KDD, they are different project concept. But if you look at the KDD, is more or less similar to the data processing steps because it is developed by computer scientists. And CIMA is from the SAS. CRISP DM is from a consortium, I think. It's an industrial-based European consortium. So they developed this kind to clearly establish the step of data projects, data analytic projects. This step must be go through one after the others. They are not single one-way process. They are iterative process. So project management perspective, we talked about that. This is introduction. So introduction, we give you a taxonomy. But of course, I don't expect you memorize. That's meaningless. But you learn some already, okay? You try out some. Some of you use decision tree, neural network, SVM. Some of you, I told you should not use logistic regression. So I remember one I don't know why you still use GLM, Generalized Linear Regression Model. I don't know why. This is not B452F. You gotta give mark for that. I told you already you should use neural network, SVM, decision tree, or random forest, but not both. Mark will be deducted if you use decision tree and random forest only. Okay, I have emphasized that, but some of you may not hear or get my message. The assignment, even we said neural network, SVM, decision tree stroke RF. So this taxonomy, I don't expect that you memorize the thing in that level. Of course, it's good if you can. Your memory is very good. You can memorize everything. But you need to at least you know the segmentations is one that we call about clustering, and prediction is classifications. That kind of that is. Project management perspective, that is the introduction unit for fee A. Unit fee. Then we have the classification. We introduce in here different classification method. Confusion matrix, hope that you are not confused by this matrix. And you know how to perform the simple speeding and then cost validation. But just meanwhile, I remember why you try to use only 3 as cost validation for k equal to 3. Why not use 10? 10 is typical. 3 is too small, I think. So the number of you need to use k4, and the k is normally I think typically is 10. Or more than 10. 3 is a little bit small. I don't know why you use 3. And some of you very interesting when we talk about the some of you try to use a ROC curve to help to explain your answers. This kind of concept, how you evaluate the models, we talked about that. And we give you a general mathematical mapping idea. It's just to illustrate the concept. This is a mapping. Classification is to map from X to Y. This is mathematically is a mapping. Just like a function. A function of x 1, 2, 3, 4, 5 up to xn to y. But how you create that map, we can use SVM. And SVM have the basic concepts. You need to, of course, you need to have some understanding of concepts. But whether you can write up this equation, that's not important. This is too fine. This is too fine. At least I think this kind of mathematical formula, if you can memorize that, you can clearly written it out when you answer the questions. Good, perfect. But that may not be a really necessary. When the question in general is a little bit high level, not down to this level. I will not ask you explicitly what is the mathematical model of SVM. That kind of question is too lower level. That it can be a question for computer science students, not for business students. So the question in general is open-end and high level. So while I'm talking about that, I will try to tell you, it's quite horrible to you when you look at this mathematics. I told you at day one, for completeness I include that, but I don't expect that you can know how to read this one. If you ask me when I read this one, I had little. I'm not pure. I do not have. I'm not a major in mathematics. Only the one who are major in mathematics, they are really good in this kind of thing. This is constraint programming. I in my undergraduate, I have some courses on mathematical programming already. So I know the basic symbols for this one. But for ARG, that kind of notation is not undergraduate times we learn that. So this is not easy for you if you do not have a mathematical programming background to read it or memorize it. Actually, you need not memorize to that level. But how about this level? I think at least you know this is not so bit too difficult, right? At least you know the concept. The mathematics is trying to do this. The mathematical model is for this one. So at least you know how to illustrate the concept. That's good enough. Perfect if you can write out the constraint, explicitly, clearly write out without any error. But I don't anticipate you can do that in the examination. Even you ask me, I can't memorize. I don't think I need to bother to memorize it to that detail. The SVM, you can find that this problem. I'm a little bit surprised because when I surprisingly good for the assignment, the accuracy of a basic model more or less them get 90 more %. So it's almost perfect models. Even you use SVM, neural network, and random forest decision tree. After training, tuning, most of them should get 90 more. That's average performance. May not be worst case can be worse. When we look at the general performance, not only the average, that's why we use cost validation. We also look at the performance in each trial. So you need to know the concept of SVM. At least this is the concept, and of course you need to know the pros and cons of each method. We talk about what is the pros and cons of SVM. Pros is based on mathematical model. Very good mathematical models. That is constraint programming actually. And but there's a shortfall when the data set is large, for example, particularly, then the training time will be very long. So it's not suitable for a large data set actually, or large dimensions, many dimensions. Neural network And you try that, but I don't know why. I never tell you you should try for only 50 iterations. The convergency, whether the training convert to the final answer, may not. Okay, neural network, the problem is that we may not be able to find the answer sometimes. The training is not convert to a stable answer. Then we say it's not converge. We need to train for a number of epochs. Typically, many epochs. 50 epochs is very small. Some of you only have set the iteration to 50. I'm surprised that do you know whether it converges or not, the answer actually. It will convert to a stabilized answer if the data set is not ill and your model is good enough, it will convert after training. Convert to a certain level of accuracy, stabilized in the answers. So the number of epochs or iterations should be quite large. That's why in the I think we use 10,000 in the tutorial. But I don't know why you turn out set 50. Maybe the time for training is too long. So you just hurry up and say set 50, then I get the answer. Then your neural network actually is not well trained. The concept of neural networks, and again, concept is very important. You need to at least you can tell me you know the basic concept. The gradient descent, I didn't tell you, as I remember the tutorial, I didn't tell you to try to tune the decay. That's the step size. That is how far it tried to because whenever you follow this gradient to go to the next point, the step size, normally at the very beginning we use large step size, and then gradually we use more step size. Otherwise, we'll never get to this point because we will overshoot, and we just go through along these two directions without going to this point. We overrun the lowest point and then go to the other side. Just like we when we're going to playing golf, pucking to a hole, we overshoot, and then we overshoot again. We just go through again and again, never go into the hole. It's just like this one, you can overshoot. So the step size or decay, that kind of concept, I didn't tell you, but I don't know why you can. You quite many of you will know how to will try to change that. Normally, in neural network in the past, when I am students, the first course I take neural network, I try to tune this number manually. I try to adjust this number. If it did not converge, I will try to increase it. So these concepts, you should be able to at least have some ideas. Of course, if you can draw a diagram to illustrate the concept, then it will be much easier. For decision tree, we also talk about the concepts and the good and the pros and cons of it. And in the assignment, many of you use decision tree, but then you just draw the tree and you didn't try to. Some of you have at least tell me from the tree which variable play more important part in categorize the data. And if you can go further, telling me more about from the graph the rules, then it will be even better. So the tree can help to identify the or when the importance of the variables. And we're talking about some practical problem that when you have a continuous variable, how you discretize this kind of concepts. We also talk about overfit, how to avoid that. Ensemble methods and random forests in particular, you try to use it in the assignments. So we see the strength of ensemble methods. Yes, but does it mean that it already outperform? No, because that's depends on the cases. Because we illustrate that the different scenario, sometimes the ensemble method may not work better than the single method. That depends on the cases. If there's such a simple, if this approach is always outperform the others, then all other methods can be chessed. But reality is not. I ask you to benchmark. You need to compare. If you just tune the model and then look at the performance based on the speed, simple speed of the data, 30% for testing, 70% for training, you tune the model and then performance on test, and then directly compare the result based on that particular speeding of the samples. That is not a fair benchmark, actually. If you use Carrot, RPark, that kind of software packages without using MLR, you cannot generate something like this one. Because this conduct cost validation, apply cost validation to fairly compare the models. So the several steps. In the first step, you build your classifier, tune the parameter, identify the best parameter set for the problem, and then at the end, create learner for that. Based on that, optimize the parameter. You use cost validation, then you generate this one. And if you do not generate that one, of course your mark will be deducted in assignment. So evaluation, the model is more than just tune it, and then based on the tuned model, evaluate for your training test set. That is not a fair evaluation. The fair one is use cost validation to do that. And we also talk about deep learning. Deep learning is a very complicated one, and so very much depend on your answers, your proposed method. This can be an important diagram when we talk about CNN. We illustrate the concept of CNN, and we also talk about recurrent network, deep learning, that kind of concepts. For classifications, and for clustering, we have general concepts about when you can use under what situation clustering may not be good, so on and so forth. That concept also help you to see the limited, because the exam style normally we will have some typical scenario, ask you for a proposal. You tell me how to solve it, and then how you can implement your proposed method, that kind of questions. So you can see you need to have a good understanding of the consideration factors. So we talked about k-means, that kind of concepts, but I don't expect you can memorize the steps, how the k-mean actually iterate. That is too low level against. But you need to understand that. Otherwise, you cannot differentiate between K-mean and other clustering. This is the simplest one. Well-known technique, well-developed, pretty easy to understand. So that's why K-mean is so successful at the very beginning. But when you propose K-mean, you need to at least know or you can tell what are the parameter, that kind of information. What parameter you tune, and what are the against the limitation of K-means. For example, K-mean at the very beginning, you need to define number of clusters. You need to define number of clusters before you can start. And the good news is that K-mean is very efficient. The computation time is very small. It can be very fast. Scalable, when it's fast, then it's scalable to large data set. If the algorithm in general is very slow, training time is very long, then probably it's not scalable to large data set. If you can understand all this concept, then everything become pretty easy for you to memorize. When we talk about whether the algorithm is scalable, we look at how the efficiency of it. If we have pool result, if we really want to go into that detail, of course, that the question is very low, become a lower level. We know sometimes we have different cases. In different cases, we have a poor result. If the it also depends on the initialization. Why we tell you the initialization is very important? Because we know that the algorithm is not perfect, depending on your start point. So that's why there's some alternative or improvement over the standard K-mean is to randomize the initialization point, or not only randomize. Normally it's randomized. Instead, try to find two extreme points to begin the clustering. So find 2 points that are not close together at the very beginning. This is one of the ways. Or multiple start, try out different start point, and then try to combine. So there's different proposed methodology. Hierarchical clustering. What is the best and worst? Of course, this diagram in the quiz only the question that normally when the student is get high mark, they normally can answer this question. When we cut the level in here, then we have a different number of clusters. The number of clusters depends on your level of cutting. But K-mean, no. K-mean, you need to start at a given K number of clusters. But hierarchical clustering, after you have this tree, then you can cut at different level. If you cut at a higher level, then you have smaller number of clusters. So the number of clusters can be various in hierarchical clustering. The dendrogram can be used to do that. So we have different link, this kind of concepts, a little bit technical details. But at least after this call, I hope that you can memorize. When you use this hierarchical clustering, you need to know you have different ways to measure the distance between two clusters. You can use single link, you can use complete link, that kind of concepts. Density basis is another one. This tells you the concepts, noisy point, core point, and border point. And how it works. It can handle irregular shape. The K-mean cannot. Okay, I told you already. It can handle irregular shape in DB scan. I think this is a good point of this one. But sometimes even it can handle irregular shape. It may not work for all cases. And we have some soft clustering technique, but we actually do not try that in the classes. The last one is expectation maximization. That's based on the statistical approach concept. This method normally is quite slow, not scalable. When the data set is large, it takes a lot of time to train. Slow convergence. That's quite technical limitation. As atomic variance, covariance matrix, I don't think you can get idea what is this one. You need not, because they build on some mathematical models, maximum likelihood estimator. In probability, we use this maximum likelihood estimator a lot. So when we have some mathematical models, then we have some limitation and assumption. And if the matrix is not, the data matrix is not of particular structure, then it may not be easy to find the answers. And Unit 4, we're talking about the test mining, test concepts, and unstructured data. So the test is unstructured data. And we talk about n-gram. Actually, in quiz, you already have a question on that. We start from the basic NLP concept. And one of the major applications of this one is about the sentiment analysis. So the typical test mining process is quite unique, is distinct from the data analytics process or data process, numerical one. So we go through all that. Particular application is on sentiment analysis. And we have some diagram illustrate the process. So again, this is a plot diagram. This is a plot diagram. And the whole process, at least you should be able to discuss the process. If your proposal method is sentiment analysis, then you need to know this process. Very much depend on the questions and your proposal methods. What you need to memorize depend on what method you propose. So each method have data analytics is quite standard. But when we have test and others analysis for sentiment analysis, we have the specific steps to follow. You need to know that one. ChatGPT is very new one. Is too complicated to you. I just added this year for completeness, so that I would like to introduce to you this concept that I think it will benefit you in long run. But it's only an overview, but even the overview is quite technical and complicated. You can see basically is based on the deep learning concepts and develop. The last one is on big data. You need to know the basic framework, big data technology. The two parts that we most important is Hadoop, that's a file system. Hadoop is a unique file system for big data, specifically developed for big data. But in this courses, I do not cover how Hadoop works because we have the other courses, BIA B452F. In that course, we will look into how Hadoop works, the mechanism, how they have fault tolerance. But in this course, no, we can't afford to do everything because I assume for my BIA students before they take the other course first. So that's why this is continuation actually. But at least you know Hadoop is a file system for big data. It's a unique system for storage the files and for the retrieval of the data. And the other that I introduced a little bit more details, map reduce. This one, at least you know how the paradigm of map reduce, the basic procedure. What is the map and what is the reduce? It's process, how it can handle the process in parallel using domestic grade computers. This type of concept is necessary. But whether you know how to map it, this is a little bit lower level. Problem dependence. This is to solve the cases, tell you how they work out. Hope that it can clarify, help you to clarify what actually it's trying to do in here for different cases. But I just remind you again that I don't expect you to you can memorize this code, which is it's not so relevant to the level of questions. And again, this is another cases. So these are all different cases. It tells you something that this model may not work for all cases. For example, in here, we still need to use the traditional way to perform hierarchical clustering before we can cluster the very large Amazon data set. It's a little bit similar to bootstrapping, that idea. We have a subset of data that can be managed using the traditional way, more efficient. Sometimes it's more efficient than using the map reduce. Map reduce, the string is for parallelism. It can perform parallel calculation using a cluster of machines. And everything is stimulus is managed by the Hadoop. The Hadoop will manage all the tasks, retrieval the file, and then go through the map reduce, and then save down the results. So the map reduce together with the Hadoop is the major framework for the big data analysis. But developed on top, we have other tools for different. We have Heath, we have PEG, we have HBase, we have Flume, we have OC, that kind of, and Burrow, that kind of different tools, Mahal, and for different applications. So they try to emulate what we have in traditional programming platform. For example, we have database engines, but how we can have database engine that run on Hadoop? So we need to have some tools. We have a similar, we can have SQL, use SQL to perform database operation on Hadoop files, Hadoop clusters. Yes, but we need to have other tools. Okay, that's all for this part. Quite many technical things. Follow the general concept of map reduce and that kind. That is for illustration, but map reduce concept is very essential when you have to use. At least if you understand the basic concepts, map reduce is basic concepts, essential and crucial to the big data technology. Okay. So again, some discussions about the success factors. That guy is managerial question, typical managerial question. Well, how can I successfully apply some technology to solve my problem? Then what are my major considerations? What key factors? That kind of questions. You should be always prepared for that. Be honest, this is similar to when you're going to work out, and you will see typically when you have project, you need to communicate when you communicate with the managerial grade or your management, of course you will not go down to the mathematical model in that details. Their consideration is not to that point. Okay, that's technical details. So hope that you can differentiate when you prepare. We not aim to very low level technical detail in the examination questions. So let's take a look on the specimen exam paper. Then I tell you. But before we end, we need to take a con. We have con questions. We still count for your today's still count for your participations. And I just the specimen exam paper, you can find it on the OLE in here. Click on the icon, specimen exam paper. We have two sessions. Session A is answer compulsory. Normally is a high level questions, and we have a little bit long case for you to answer the related questions. The second session will be a 2 hour fee. 2 hour fee. So you need to pick up and answer 2 questions. And each question normally will have multiple parts, sub-questions. But a sub-question can have more than one question mark. Bear in mind when you answer questions, not only in my course, I think, a well-structured exam paper, normally a question may not be one question mark. Can be more than one. It's likely can be more than one, depending on the marks. If only 5 marks, normally it's just one question. But if 10 marks, can have 2 question marks. You need to answer both, not only one particular part. If you just answer the A, what is the major difference between EM, clustering, and K-means? Tell me. You do not answer what the advantage or a disadvantage of the particular clustering. Then you will not completely answer the questions. You can only get most likely half of the marks. That's 5 marks. Or maybe less, depending on the weighting of each. So don't overlook the questions. My question normally will have more than one question mark. Normally. Okay. Most of them are open-end and discussion questions. I just showed you, I cannot give you because the school do not allow us to upload the past paper. You can get this past paper in the library. Okay? Pretty similar. You have the cases, then you may need to identify something, maybe, all depends. This case is about the type of analytics. And explain the function, discuss how the analytic help analyze the athletics injuries. So you need to refer to the case. This is a K questions. Then you need to try to pick out the related points to support your discussions. Okay, this is mini case. This is not half a case. It's quite straightforward. Not noisily case written style. What mean the noisily case written style? Normally, when you read Harvard cases, the cases can be 20 pages. Inside, they tell you the story, background, history, and then tell you a lot of things. They do not try to clearly present the problem to you. That is real case study. But this is simple cases, straightforward. At least you of course, you cannot just copy the sentence as your answers. Even though that question is related to questions, you must reformat it, express it in your own way, and try to extend it. Don't just copy the text from the cases and put it as your answers. Then normally you cannot get good mark. This is not for my courses, for any case study courses. Okay, when I joined the OU First year, we have master student in business, in e-commerce. Every year in the exam, we have a Harvard case for them. So I know what is Harvard cases. I read quite a lot of Harvard cases before. Normally, you need to refer to the cases and try to find related parts to support your discussions. So then once you see we have more than one question. What is crispy DM methodology? Briefly explain. This is already good. You start going to illustrate your answers. This is very straightforward questions, but unlikely to be this year questions. And some questions may be a little straightforward. Some questions can be open-ended. So you can see we have, for short questions, we have different type, more than one question mark. So you can take a look of this paper in the library. So I can tell you for this year, actually every unit we will have questions. You can see here, even in the past, we have every unit we have questions. But sometimes a question can cause units. Okay, part A may be in Unit 3A, part B may be in Unit 3B, so on and so forth. Need not to be a question only on a single unit. But most of the questions this year will be open-ended in nature. So the answer is subject to your proposal. Actually, this kind of question is good to you. If I ask you, tell me how the SEM work, the mathematics, you surely will die because you easily make mistakes. When the question is open-ended, providing you can prepare, you have a good knowledge, basic knowledge, then you write up your answers. Justify your answers. This is more important. You need to justify that your proposal A. Okay, let me summarize. You need to propose methods, you need to know how to do it, and then tell me how to do it. That kind of question is typical you will see in my question style. For this course, I focus on the apply, not on the detailed theory behind. But at least if you talk about MapReduce, you know what is MapReduce, what is the step. That's not over demanding, I think. That's basic. When you tell some people you know what is MapReduce, at least you can tell, oh, there's 3 steps, and what each step they're trying to do, and their roles. That is not over demanding questions. If I ask you to tell me the SVM, write down the mathematical models, then it's over demanding on you. I will put it this way. Okay. I think that's all for today's, and we need to. I need to take the eye attendant.